All right, so here's our first reaction. All right, thank you guys.
So this has been soaked in isopropyl alcohol.
Oh, that's a cool picture.
And our bill is not burned, so yay!
Yeah. Oh, the green one's cool.
Alright, so you got lithium on the far right, NaCl right next to it, then copper that's burning that nice bright green right there, and then at the end is potassium. The potassium is a bluish, purplish color. The lithium I think just started turning a little red. There we go. Now it's kind of going. And yeah, that's the flame test for you.
It's just rust. Okay, so it's kind of reddish, right? You guys seen rust before, right? And this is just aluminum powder. So I'm going to mix them together at a basically like a 1-to-3 ratio. Okay, mass ratio. So you guys can see, if you guys want to get closer, right now it's not dangerous. You guys are welcome to take a look what I'm doing. So this is just rust. Can you guys see the reddish color?
Mm-hmm.
And this is aluminum powder. Gotta make sure it's aluminum. And this is the powder form, this is not the metal shavings. Okay. So now I'm just gonna go in there and I'm gonna mix it really well. So this is a redox reaction that is that involves two solids. Most of the time you guys see a lot of those solution-based redox reactions, right? So I'm going to try to mix this well. There's some chunks in here, so I can't mix that perfectly. One thing I forgot to mention is underneath there are actually some holes. You guys see the holes? So both of these actually have holes in them. So that way, because this is a very exothermic reaction, I don't want this to explode on you guys. So what will happen is once the metal once the iron metal is actually, the metal ion is reduced to the iron metal, it's very hot, so it's actually molten iron. So it's actually going to trickle down through the 2 holes and burn through the filter paper. It's going to trickle down into, I just have a bucket of sand down here. Okay, so that metal is going to be really hot, so it's going to take a while for it to cool down. Fortunately, it's quite cold today. Alright, now by itself it's not really going to do anything. We actually need to spark it a little bit with a little bit of a catalyst. So we need to start the reaction with a little bit of a initial boost. So what I'm going to use is a mixture of potassium permanganate. Potassium permanganate, when you react it with glycerol, potassium permanganate is a very strong oxidizer. It's a very strong oxidizing agent. So actually it will take glycerol and produce carbon dioxide gas. So you will see carbon dioxide gas form first, and it's going to create a tremendous amount of heat that will kickstart this reaction, and then you'll see the rest of the reaction. It's actually very bright, so don't look directly at the flame. Okay?
In that case,
Help if I can see. Okay, that's good. So this is glycerol. It's a very thick solution. So I'm just going to pour it onto the potassium permanganate, and then it's going to oxidize. Okay, and then watch for the smoke, and then immediately, hopefully, if this works. This is my first time doing this, by the way. Dr. Perkle is the expert. I am the trainee. Okay, here we go. There's the molten iron.
oh my eyes.
If you guys want to come over and take a look at the molten iron, don't touch it, obviously.
It looks like lava. You looked at it?
The hole's right here on this side, so I'm just going to seal it and then put the pipette in and squeeze it. We'll see if we can get started. So it has to be done pretty quickly. Alright, we got lost this time. Here we go.
No, the thing's probably like 60 feet, 60, 80 feet.
Alright, this one will be loud.
Oh, boy. Okay.
is just hydrogen and air, 1 to 1.
Sounded like a subwoofer grill. It's not. It's
So guys, a clarification. So in this case, remember this hydrogen and air is 20% oxygen, right, roughly? So right now we have, what's the 2 to 1? All right, so this is a combustion reaction. So if you have air with a little bit of only 20% oxygen, that's what you saw. Now we have a 2 to 1 ratio of only hydrogen to oxygen. So there's more oxygen now. So you should expect a bigger boom. Right?
God! Oh my God! Whoa!
Oh my gosh.
So we thought about. So obviously you guys saw how much bigger of a boom that was, right? So we figured, guys, why do it once when we can double it up for twice the fun, right?
Oh
Hold on. You're closer.
no, don't no. Definitely.
Phone camera can't see it. Mic cover right here.
Definitely don't get closer.
Yes.